Alright, welcome back class. This is Mr. McElveen again. Today we're going to talk about how to find the area and the perimeter of composite figures. So before we get started, let's talk about what a composite figure is. There's your definition of a composite figure. It's a figure that can be divided into more than one of the basic figures. And when we talk about basic figures, we're generally talking about things like a rectangle, a square, triangle, or trapezoid. Nope, forgot one more. And the circle. Okay, so those are our basic figures. When we talk about a composite figure, we're talking about taking those figures and putting them together to create a new figure. And we're going to talk about how to calculate the area and find the perimeter of such figures. So let's take a look at an example. So here's our first figure. So what we have is what looks kind of like a boot. When you check your formula sheet, you'll notice we don't have a formula to find the area or the perimeter of a boot. So let's take a look at this figure and see, well, what can we divide it into? Well, it looks like that you have a rectangle that has a triangle added onto it. So to find the area, all we would have to do would be to calculate the area of the rectangle and then the area of the triangle, and then add those two together, and then we would have the area of the entire figure. So that's going to be our strategy here. All right, so let's start with the rectangle. As we all know, the area formula for a rectangle is length times width. So let's identify the length and the width here of this rectangle. So it looks like we have a length of 5 and a width of 4. Now, some of you may say, Mr. McElveen, what about this guy right here? What about that 7? Why isn't the width of 7? Well, the thing you want to pay attention to with that is this measure of 7. That's the distance from the rectangle all the way out to the edge of that triangle. That's how long your foot would be if this would be your boot. So that's going to include both the rectangle and the triangle. So that's not going to be the width of just the rectangle. So that's why we're only going to use 4 there. So to find the area, we just need to substitute in our formula. So we're going to do 5 times 4, and then we know the area is going to be 20, and that's going to be inches squared. So 20 inches squared is going to give us the, hold on, there we go. That's not it. Sorry, guys. There we go. That's what I'm looking for. So this space right in here, nice rainbow color. The area of all of that space inside there, that is going to be 20 inches squared. So now we have to figure out the area of that triangle. Okay, and so to do that, we just use our area formula for a triangle. So area is equal to 1/2 the base of the triangle times the height of the triangle. Now, this is where things get a little interesting, because if we look just at the triangle, we don't see any number here, there's no number there, and there's no number there. So at first glance, it appears as if we don't have the dimensions of the triangle. But what we're going to do is we're going to take some of our other numbers and we're going to look at those. And so to do that, I'm going to erase all the notations in there so we can look clear and fresh. We're just going to remember that our area is 20. We'll write that in the corner so we don't forget. So notice here we have this measure of 3 inches. And that 3 inches covers from the edge of the rectangle right there to where the triangle starts. That's 3 inches right in there. So the question is, well, what is this? What is this measure going to be right here? I'll put that in red. Well, what do we know? Well, we know that if we draw this line straight across, that if this measure is 3 inches, that this measure here is also 3 inches. And we were told earlier that this whole side here was 5. Sorry guys, I meant to do that in green. This whole side here was 5. So what we see is that if the whole thing is 5 and this part here is 3, that means that this measure here has to be 5 minus 3, or 2 inches. And if it's 2 inches over on the left, then it has to be 2 inches over on the right. So now we have the height of our triangle. The height of our triangle is 2 inches. So what we're left with now is, well, this distance right here. This is going to be our base. How are we going to do that? Same logic as before. I'm going to erase all of this so we can see. And we'll see here that we talked about the width of our rectangle being 4. And then remember, our rectangle comes down here, which means that this measure is 4 inches also. The measure from there to there is 4 inches. Now we know that the whole distance is 7. We talked about that earlier. Well, if that whole distance is 7 and this piece right here is 4, then that means that this piece would have to be 7 minus 4, or 3 inches. So now we have a base of 3 inches for our triangle. So just to clear that up and make sure we all see it, what we're talking about here is we're talking about having a triangle with a base of 3 inches and a height of 2 inches. And then so we can simply calculate that using our formula. 3 times 2 is 6, half of 6 is 3, so my area is equal to 3 inches squared. So my triangle was 3 inches squared. My rectangle from earlier was 20 inches squared, which means the entire figure has an area of 23 inches squared. We calculate that simply by adding those together. So that's how we find the area of that composite figure. Now let's talk perimeter. Remember, perimeter is the measure around an object. So at a quick glance, when we look at this, we might say, oh, well, the perimeter is going to be easy. We're just going to add 3 inches to 4 inches to 5 inches to 7 inches, whoops, and then I will be done. But there's a small problem with that, because if we do that, what we've done is we have forgotten to calculate that. How far is that? That's not included in the perimeter of those 4 numbers. We've got 1, 2, 3, 4 numbers there. 1, 2, 3, 4 numbers, but we're looking at a total of 1, 2, 3, 4, 5 sides. We're missing a number. So we have to have that other number in here. So what we have to do is we've got to calculate that, and that's going to be very specific to each particular shape. Now, this one is going to require us to use one of our previous theorems, the Pythagorean theorem, because we need to focus on this right triangle right here. We need this slanted side, which we call the hypotenuse. Now we remember from calculating the area earlier that the height was 2 and the base was 3. So we're just going to use our Pythagorean theorem and then calculate our other side, which we're going to call the hypotenuse, or c, in our formula. So remember, our Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs. In this case, the legs are the base and the height. So we're going to go 2 squared plus 3 squared is equal to c squared. We square 2 to get 4. We square 3 to get 9. And then 4 plus 9 is 15. So we're looking at 15 is equal to c squared, so that the measure of that side is going to be the square root of 15. And for calculating the perimeter, the square root of 15 would not be useful, so we'll want a decimal equivalent, which will be 3.9. So that fifth side we're going to add to our perimeter is going to be 3.9 inches. So we are looking at a total perimeter for our figure of 22.9 2.9 inches. And remember, perimeter is one dimension. It's measured around, so we're just going to do inches and not inches squared. So in our previous example, we had a rectangle with a triangle added onto it. We found the area by separating the two. So now we're looking at a slightly different problem. So in this problem, we have what appears to be a squared donut. We have that shaded area, which you might think of, hey, that looks like a square donut, with a hole cut out. And what we want to do is we want to find the area of the shaded region only. So how are we going to do that? To find the area of the shaded region. So to find the area of the shaded region, what we're going to do is we're going to subtract. Before, remember, we found the area of the rectangle and the area of the triangle, and we added them together. Now we have two squares. We're going to find the area of each square, and we're going to subtract them from one another. So let's start with the big square. So with the big square, we have one side is 3. Remember, it's a square. If one side is 3, all sides are 3s by the nature of a square. So 3, 3, 3. Okay, so the area of that large triangle is going to be 3 squared, or side squared. So that's going to be 3 squared, which will be 9. So we're talking 9 centimeters squared. That's the area of the shaded region. So now we want to, the area of the large triangle. So now we want to find the area of the small triangle. So the small triangle is here, and you can see it's labeled, it's 2 by 2. So the area of that small triangle is going to be 4. So again, area of a square is side squared. The side is 2. 2 squared is 4. So we're talking 4 centimeters squared. Now, recall that 9 is the measure of the whole big square. The whole square has an area of 9. What we want to do is simply find the area of the region that's shaded. So we're going to take 9, which is the area of the entire triangle, and then we're going to take 4, which is the area of the small triangle, and we're going to subtract them. So 9 minus 4 is going to give us 5. So 5 centimeters squared is the area of our shaded region. All right, and we're happy to find that, so we're going to fill that in with smiley faces. So that shaded region, that area that has all those smiley faces in it, that is the area that measures 5 centimeters squared. So notice, subtraction instead of addition. All right, so now I'd like you guys to try this one on your own. So now you can see we have what appears to be a very funky L-shaped style figure. So I want you to calculate the area and the perimeter of this figure. So you should have divided this one into 2 rectangles. The first smaller, skinnier rectangle here ends up with an area of 16 centimeters squared, and the larger one ends up with an area of 21 centimeters squared. Please ignore my decimal point. That should be 21 centimeters squared. And then we combine them for a total of 37 centimeters squared. Some of you may have just subdivided this one slightly differently. You can see often there's not only one way to subdivide these composite figures. For example, in this case, you could have subdivided it into a longer, skinnier 15 by 2 rectangle, and then a 7 by 1 rectangle. And you'll notice when you combine the two areas, you still end up with the same 37 centimeters squared as the area. Now to calculate the perimeter, we need to add all of the sides together, and we'll notice they give us 4 of the sides. However, we have one big missing side there, and we need to calculate that one. You'll notice the side that's 15 centimeters. We notice here we have 7 centimeters. That means the opposite side of the rectangle would also be 7 centimeters, which means the next side would be 8 centimeters. So again, the opposite side from 8 is our missing side, so it must be 8. So that means that we have a total perimeter of 35 centimeters.